Good day. Welcome to another class. Today's class is on paired sample t-test. Why do we conduct this test? The aim is to compare the same group of sample of data sets where you want to check whether there is a difference before something happened and after something happened to the same group or the same data set or the same information. So here I have 25 students who undertook a number of tests like mock and preparation tests before they went for their final exams. And you can see their pre-test, the total scores that they had in all the tests that they took, 25 students. And then you can see here also after the tests, the main test, the results that they got. So we want to compare whether there is any significant differences between this same students, whether there's any difference between them. So here I'm going to use the pair sample t-test. And here I'm assuming the data set is parametric. If you want to know why this data set is parametric, check my other videos. I have a full video on the differences between parametric data and non-parametric data. Okay, good. So here I'm assuming and I'm hypothesizing that there is no significant differences between the pre-test scores and the post-test scores. And then that's my null hypothesis, and my alternative hypothesis is that there are differences. So I want to check this, whether there is any significant differences between this or there is not. Okay, so to do this, I'm going to use two softwares or tools. I'm going to use the Excel here, and then I also go to the SPSS to make our work easy. So I'm going to start with the Excel. So with the Excel, this is what I will do. I will just go to data analysis. Come here, you click on data, you click on the data analysis, and then you go down. When this dialog opens, you go down and select the pairs to sample for means. You select that one, you select OK. And with the OK, you just put in your data set. So I'll first highlight or capture the pretest for the first variable 1 range and variable 2 range. We'll capture the post test. Okay, so normally if you have any hypothesized mean difference, in this context, we assume there's no difference. So the hypothesized mean difference will be 0. But if you have anyone, because sometimes you'll be testing some things, maybe there's already a difference that you have already established, like 10, 20, 50, something, whatever, you can put it there. But here we assume the 0. Okay, the labels, and then I will just look out for where I'll put my results. So I'm going to put my results somewhere here, close to what I have. And then if I want to change, this is the significance level, which is 5%, but if I want to change it to 1% or 10% or whatever percent, I can do that. So I just click OK, and the results will come out. So this is the results. And as you can see, the results is showing the mean of each of the tests, and then the variances, the number of observations, which are the students, 25, 25, the correlation between the two group of data set, the pre-test and the post-test, and then the hypothesized mean, as you can see, which is 0. The most important thing to focus on is the p-value. So if it is either a 1-tail or 2-tail, what we can see or what we are seeing is that the 1-tail is 0.12842, and then the 2-tail, the p-value is 0.25683. The 1-tail is 0.1284. Okay, so with the two of them, whether it's a 1-tail or it's a 2-tail, what we are seeing is that the two of them are greater. They are greater than the p-value, which in this p-value, I mean our significance level of 5%. And because they are greater than that, what we are going to do is that we are going to accept the null hypothesis and reject the alternative hypothesis. But if the answer were to be opposite, where we had the p-values being less than 0.05, then we'll reject the null hypothesis and then accept the alternative hypothesis. Let's go back and revisit the hypothesis and make a final decision. So based on the two p-values, whether it's a one-tail or two-tail, what we are seeing is that we are having values which are greater than the significance level 0.005. Therefore, we have to reject the null hypothesis and accept reject the alternative hypothesis and then accept the null hypothesis. So our conclusion from here is going to be that we'll pick the null hypothesis. And what does the null hypothesis says? What does it say? It says that there is no significant difference between the post-test and the pre-test. So that's going to be our conclusion, or we'll conclude that in this data set, there's no differences between the two of them. There's no significant difference between the pre-test scores and then the post-test scores. Okay, so that's one approach using the Excel. Now let's go to SPSS. So if I want to use the SPSS to do the same work, what I would do is that I'll just copy everything. I'll copy the same data set I've used here. I can decide to forgo the student IDs because it will not really be important for the analysis. The main analysis is going to be based on the scores, which is the pre-test and then the post-test scores. But you can copy everything and just bring them here. So you copy, you bring them here, and then what you do is that you go to, from the data view, you go to the variable view, and then you made mention of what these things are. These are the student's ID. The first one is the pre-test. Then the second one, okay, let me put it pre-test. And this is the post-test. Okay, so this is, the first one is a string, yes, but the second one is not. The second and the third, which is the pre and the post-test, they are scores. So they are numerical. They are not a string. So you have to change them. And then when it comes to the scale, yes, the first one is a nominal. And then, but the other ones, which is the pre-test and the post-test, because they are numerical, they are more of scale, with interval ratio. This case, kind of interval. Okay, so once you set these things or you make changes to this, we now come to the data view and you see that the data set has been arranged properly. You have everything. Okay, so what next? The next thing is to do the test. To do the test, you go to Analyze, and then you select Compare Means and Proportions. Within the Compare Means and Proportions, you select Pair Sample T-Test. Paired Samples T-Test. You click on that. This will open, and then you push the pre-test to this. And then with the post-test, you put it to the second variable. Once these are done, then if you want to make any changes as far as this part is concerned, you can do that. But normally these are defaults, so you can just leave them as it is and go ahead and run your analysis. You can look at all these things. And even if you want to change any of them, it's acceptable. So you click OK, and the results will come on. Now let's look at the results. So we are getting the same thing in terms of the mean, and the observations or the sample size, and then the standard deviation, the standard error. So this is a correlation. We are getting the same values. The correlation are significant because they are less than 0.05. Yeah, there's a strong relationship between them. However, even though there is a strong relationship in terms of association, there's no significant differences between them. Why? Because if you look at the pair sample table and you look at the p-values, you can see that the 0.128 for one tail, and then the two tail 0.257. That's exactly what we saw or we got from the Excel. That's the same thing that we got from the Excel. So we also make the same conclusion. We got these two values, whether it's one tail or two tail, p-values, they are greater. The two of them, they are greater than 0.05. This and that, they are greater than 0.05. Therefore, we will make a conclusion by saying that we accept the null hypothesis and reject the alternative hypothesis. And the null hypothesis in this context says that there is no significance between the two tests, whether it being pre-test scores or post-test scores. There's no significance difference between them. Thank you very much for your time, and I wish you the best. See you in my next class for a situation where we assume that the data set is non-parametric. What do we do? What kind of test do we run? Thank you very much. Have a great day. Bye.